welcome. Here are the notes for day 3 of Unit 19. All right, so we're going to be looking at a few graphs today and then identifying if functions are inverses. That seems weird for a sec. Sorry, my numbering seems to be all over the board. No worries, all good. Anyways, okay. So when you're looking at the domain of a function or a graph, you're looking at all the x values used. And we're looking sometimes for specific numbers. Sometimes it's positive infinity or negative infinity. We're looking from left to right. All right, if you ever have something with arrows, we got to think of negative infinity to positive infinity. But the focus is we are looking at all the x values used to make that graph. So I'm going to hop down to the one right below it. So as we're doing this, we see from the left side, we're going up this way and keep going this way and this way and this way and keeps going with the arrow. I am looking at all the x values used, and I want the smallest one first. So remember, way going this direction is positive infinity. So I want to start on the left side and work my way to the right side. Sorry, that was weird. Anyways, I want to figure out my starting point here. To do that, I would say, okay, this exact point uses that x value. So that is my starting point on the left. So the domain is from -8 for the x values. And even though the graph is up, it keeps going this direction, to the right, to the right, to the right. And since it keeps going on and on and on with an arrow, we know that it goes to positive infinity. We don't know when it stops, so we just say, hey, it goes to infinity. All right, so when we're doing this, is this called interval notation? Anytime you see a either negative infinity or positive infinity, you use a parenthesis around it. But if it's a number with a closed circle, we use a bracket around it, saying this is equal to -8. That's our first input or our first x value we use. And the graph goes completely to the right side towards positive infinity. Now, if the domain are all the x values used going from left to right, the range are all the y values. Is going from down, so the smallest one, to up. So the smallest y value, or the minimum, up to the max. The min to the maximum. The smallest the graph goes down to the largest the graph goes up. All right, so let me get rid of this thing. So when I'm looking at the graph for the range here, I want to say this graph, the furthest it goes down here is right here at 3. And the highest it goes up here is at 6. So it goes from 3 up to 6, and it keeps going straight and stays on 6. So I would say the range is from the lowest is 3. The lowest is always on the left. And to 6. Since these are exact numbers, you use a bracket around 3 and a bracket around 6. All right, so sometimes it helps. You might want to think about it. If I highlighted on the x, I start here and go completely this direction for the domain. For the range, I say, oh, The range starts here at 3 and then goes up to here at 6. So this is the domain. And this is my range. That's what you're doing, is identifying them separately. Instead of listing all the x values used for the domain and all the y values are used for the range, you're essentially telling me the starting and stopping point. Okay. Now moving over here. Okay. So the graph we are using, a little bit smaller here. The graph we are using is kind of hidden, has an arrow here, goes completely here and keeps it, just keeps skipping right along the y-axis there. So in terms of x's, this is negative infinity over here, the 0's right here, and keeps going, and positive infinity is there. So we're looking at our x's. The graph starts here. All these x's are used, and all the x's are used up until we think about there. Let me change a different color. No, not purple. Something obnoxious. Oh, that's obnoxious. Oh, well. Okay, never mind anyways. Sorry. So the domain, we're looking at our x's. We're saying how far left is it going? And since we have the arrow, it's going towards negative infinity. And how far right is it going? And it has a stopping point. It's not looking like it's crossing there. So we'll say up to 0. And 0 is an exact number. And this is a graph of a logarithm function we're going to talk about coming up next semester. Okay, the range. The range is how far down is the graph going, and with this arrow it's going way far down, so negative infinity. And then how far up is it going? Now it's going like this, but it's going up, up, up. Well, up, 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 up. So I don't know when it's stopping. So when you see an arrow, on it, and you just got to assume it's going left and it's going up, 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 up. So the domain is how far down, the minimum, negative infinity, and the maximum, well, we don't know that what the max is, so we say positive infinity. Okay. Go ahead and go to the next page if you feel like, okay, I want to try this on my own. Fantastic, go for it. Pause this. The domain are the x values. It's sometimes nice when you do see the starting or stopping point. Say, okay, this is here, and it's going this way, this way, this way, this way for my x's. So that's my domain. It's kind of nice sometimes when you see those. So we start at 4, and it keeps going to positive infinity. That's the domain. The range is how far down. So it goes down to here. And then it goes up, 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 up. I know it's going up slightly. It doesn't look like very much, but it is going up, up, up. So for the range, the lowest it goes is 0. It's the y's. The smallest y value is 0. And it goes up, 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 so positive infinity. All right, sorry, I just had to grab a couple paper copies. All thrown off by something. Hold on, nope. Oh. Yeah, the numbering is definitely off, but whatever. Okay. No big deal. All right. So sometimes it helps if you need to highlight the graph. The graph is here and it goes there. So you've seen how far left and how far right is it going for the domain. So it keeps going to the left infinitely, so negative infinity, and to the right positive infinity. And because it's not exact, we put parentheses. And the lowest it goes is negative infinity and positive infinity again. Those linear ones are very nice. Whenever you see the lines with double arrows on them, so no curves to them, but just lines, they both have infinities, negative and positive for the domain and ranges. Okay, so if you need to look back at these, we're going to start talking about these and doing domains of functions and stuff, and talking about the inverses in the domains and some other things. Now, we're kind of switching gears to something I skipped on last time I saw you. We've done a lot of stuff where we said, hey, these are inverses, okay, or find the inverse. But what if I give you two functions? So like on this one, I give you two different functions, the two different equations, and I said, hey, are these inverses? Verify if they're inverses. So you're going to do composition, and composition is where you take the one and plug it into the other, and we want to look at the outcome. And so if you're given two functions, f of x and g of x, if we do this, we take one function and plug it into the other, so we do f of g of x, and we simplify as much as possible. And we want to see, does it equal just the variable x? If it does, then we move and we reverse what we did. We do a second one. And we see again, does this equal x? Now, the functions will not always be labeled f and g, but you're going to use the two functions together. So if one of them you go through and you simplify and equals x, then you go on to the second one. It is possible for it to work one way and not the other. To be inverses of each other, we need to check and see, does it work one way? If it equals x, great. We move on to the next. If it doesn't equal x, we stop and say they are not inverses of each other. All right, so for these two functions, I want to first check, it doesn't matter which one, I'm going to take one and plug it into the other. So here's what I'm going to do. I'm going to take the g function. I'm going to take the g function. And I'm going to plug it into the h function. So I have 2 minus 3 over 2, then minus 3. Now I'm going to simplify one thing at a time. Do not just start smashing stuff, crashing stuff out here. There should be some stuff that cancels. So for example, this multiplying by 2 and this dividing by 2, they will cancel each other out. Cancel one thing at a time. So I have x minus 3 inside parentheses, and another subtract 3. If I simplify these now, I get x minus 6. So I can't do anything else. I'm looking for it to just equal x. If it equals anything other than just x, they're not inverses. You do not do any more to this problem. Because this is equal to x minus 6, this is what we're trying to look for. We're just trying to see if it equals x. Because it equals x minus 6, we can automatically say these are not inverses. We do not need to do it the other way. If one way works, great. And by working, I mean it simplifies to x, then we check the other way. But if it only does one, if it doesn't equal x, then I don't even go on. I don't need to. I know they're not inverses. Okay, so here's a different one. All right, are these inverses? So I'm going to take 1 and plug it in to the other. So my m function, I have x plus 3 to the third. Now I'm going to take that and plug that into the f function. There's a lot going on. All right, so the f function. So I take this cubed root. I put x plus 3 cubed on where the x is, and then I subtract 3. So this is the first way I'm trying it. Now I can start simplifying. I do a little bit of a time. A cubed root and a cube cancel each other out. So one thing at a time, not more than one. Okay, now I see I have a plus 3 and a minus 3. I can cancel those out, and I end up with just x. All right, that's what we're looking for. If they are inverses, this is what we should end up with. They should end up to just be an x. If we do get just an x, it's different than the other one. We didn't end up with just x. We ended up with x minus 6. We reverse how we plug things in. So I started with f on the outside, m on the inside. Now I reversed it. I put m on the outside. Oh, kitten. Emerson. Okay, I reversed the order of the letters. All right, so I plug the f in. I get cubed root of x and minus 3. That's the f function. I'm going to plug it in to the m. All right, so where there's an x, okay, cubed root of x minus 3, then plus 3 cubed. Now, don't go all crazy trying to simplify. One thing at a time. Work with your parentheses. I have a minus 3 and a plus 3, so those two cancel out one at a time. So I have cubed root of x to the third. I can cancel a cube and a cube. So now I'm just left with x. And since they work both ways, this is what we're looking for. If you plug it in one way, you get x, and then you reverse it and plug in the other way. These are inverses. And again, if one of them does not work to come out, work meaning it doesn't come out to an x, something else, 2x, x minus 7, whatever, they are not inverses. All right, so try your hand at your homework. A little bit of review on some of them. Some of them are going to look a little bit funny. So just see what you can do with those. A little bit of graphing, do the inverse of the graph, make an equation, that sort of stuff. So try your best. Let me know. Catch up on your other homeworks. And let me know if you have any questions. Talk to you soon. Bye.